Hi there, you're with Mr. Laurie, and this is lesson number 4 of linear and nonlinear relationships. We have had 3 lessons on straight lines, and now we are moving on to parabolas. Today we'll be looking at special forms of the parabola. So let's get started. First of all, what is a parabola? We see parabolas in everyday life. When a ball is thrown up in the air and comes back down due to gravity, the arc that it traces out is a parabola. But algebraically, what's happening? Y equals x. What type of graph is that? That's a straight line. And if we add something to the x, or we multiply the x by a number, that'll change the steepness and the position of the straight line. But what happens if we add a power? What type of graph is this? Well, a good way to have a look at what type of graph we might be dealing with is to plot a table of values. So let's do that now. Okay, so what values do we get for y when we substitute these values of x in? Let's start with 0. When x equals 0, y equals 0 squared. What's 0 times itself? 0. Let's look at the other positive numbers now. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So we're just looking at our square numbers. And that would continue, 4 squared, 16, and so on. What about when we substitute in negative numbers? Remember, when a negative number is multiplied by itself, the answer is positive. So negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9. So we can see a symmetrical pattern going on here. Now that we've got a table of values, we can graph the coordinate points. So let's do that now. You'll notice that we've only got the positive part of the axis here because none of our y values are negative. Alright, so 0, 0 was the first point we came up with, and that's right here at the origin. Then either side of that we had 1, 1, and negative 1, 1, 2, 4, and negative 2, 4, and finally 3, 9, and negative 3, 9. Let's connect these points now to complete our parabola. We want to make sure that our parabola is curved at the bottom and not pointed. Okay, so this graph is what we would call the standard parabola. But let's have a look at y equals negative x squared. When I say y equals negative x squared, I'm referring to this and not this. Like we talked about before, a negative number multiplied by itself is just the same as the positive version. Okay, but here we have the negative outside of the x squared. It's just the x that is squared. Alright, once again, let's have a look at a table of values and then we'll plot the points. Starting with 0 again. 0 squared is 0 and negative 0 is still just 0. Let's have a look at 1. When x is 1, x squared is 1, but now we have negative 1. And looking at x equals negative 1, from the last graph we know that negative 1 squared is 1, but we have the negative version of that as well, negative 1. So hopefully you can see what's happening here. We're getting the same numbers as before, except they're the negative versions. When we substitute in 2, we get negative 4. And when we substitute in negative 2, we also get negative 4. And the same for 3 and negative 3. We get negative 9. So when we graph this, we're just going to get a mirror image of the first graph about the x-axis. Let's graph it now. 0, 0 is still in the same position, but everything else falls below the x-axis. We have 1, negative 1, and negative 1, negative 1. We have 2, negative 4, and negative 2, negative 4. And finally 3, negative 9, and negative 3, negative 9. Connecting these coordinates, just like before, gives us our parabola, except this time it's facing downwards. Alrighty, now that we've looked at the standard parabola and some features of parabolas, let's have a look at what happens as we change and move a standard parabola. And to do this, we're going to use the graphing software Desmos. If you're ever doing any questions that involve graphing, Desmos is a highly recommended piece of software. You can just jump online and use it for free. Anyway, let's have a look at how it works. Firstly, let's just put in, well, just quickly, y equals x. There's our straight line. Okay, and we know that if we say add 1 to a straight line, it moves it up slightly. Or if we add 2 or 3 or 4, etc. We also know that if we change the value of the coefficient of x, 2x or 3x or 4x, okay, or we make it a negative, it changes the steepness and direction of the graph. The same kind of properties apply when we're dealing with our parabolas. So here's our standard parabola, y equals x squared. Let's see what happens if we change the coefficient. Instead of 1x squared, let's make it 2x squared. There we go, we can see it's steeper or narrower now. What about if we had y equals 10x squared? A lot steeper, a lot narrower than the original graph. What if we go the other way? What if we take a value that's less than 1? We know negative values will completely flip our graph upside down, but if we put a coefficient that is, say, 0.5, so it's still positive, we now have a flatter or wider graph than our original. So just comparing our original graph with this new one, we can see that y equals half x squared is flatter. If we kept going and made it even smaller, we're at y equals 1/10 x squared. A lot flatter, a lot wider. Okay, so changing the coefficient of x squared changes the steepness. What about if we move our original graph around? Let's start by adding on 1. There we go. We've moved it up 1, or 2, or 3, or 4, or 10. Likewise, if we take away, we move our graph down. So still the exact same graph, but it's just been moved up or down. Now we're going to move our graph sideways, and we do that by putting the x component with a plus or minus inside the bracket, so everything gets squared now. Alright, now that might not have been what some of you would expect necessarily. For x minus 3 all squared, gets moved in the positive direction along the x-axis. And let's think about this. If we substitute in x equals 3, we get 3 take away 3, which is 0. 0 squared is 0. So the new vertex is at 3, 0. So what would we have to do to move our original graph the other way? If we wanted to take y equals x squared and move it to the left, what might we do? Well, we would want a negative x value for the vertex. So we will have to add on a number. There we go. Y equals x plus 5 all squared has been moved 5 units to the left. Now has a vertex at minus 5, 0. So combining what we've just learned, we could move our original graph up and down or left to right, as well as change the steepness of it. If we had to put a parabola that is the same as what we've got right now, the same as the standard, but it had a vertex at the coordinates -2 plus 7. -2, 7. What would the equation look like? Well, we are wanting to move it 2 to the left. So we would add 2 within the brackets. But we also want it to have a vertex not at -2, 0, but up at 7. So we would add 7 on to the entire equation. So y equals x plus 2 squared plus 7 would move our parabola so that it has its vertex at -2, 7. That's just one example. We could move it in any direction we want. And keep in mind that if we make our parabola negative, it flips it upside down. So just like we can take our standard parabola and make it negative and flip it upside down, so we can do the same with any other parabola, even if we have moved its vertex. Alright, so let's go back and write some notes to summarize. Alrighty, changing and moving the standard parabola. So if we start with y equals x squared, that is our standard parabola. But what about when we change the coefficient of x squared? So instead of being 1, it's now some number a. What happened? Well, if a was set to be bigger than 1, the parabola got steeper or narrower than the original. If we set it to be smaller than 1, but still bigger than 0, say half, the parabola got flatter or wider. Remember, if the coefficient becomes negative, it's exactly the same, except it's upside down. It's concave down. Alrighty. What about moving it up and down? If we had our standard parabola and we added some value, okay, what happens to our parabola? This moved our parabola up. If we plus 2, we moved up 2. If we plus 3, we moved up 3. So if we plus k, we moved up by k. And that changes our turning point or vertex. Instead of being at 0, 0, it would now be at 0k. Likewise, if we subtracted some value k, this would move our parabola down. Minus 3 would move our parabola down by 3. Minus 10 would move our parabola down by 10. So minus k moves our parabola down by k. And our vertex is 0, negative k. Finally, moving our parabola left or right. If within some brackets we added or subtracted a value, this is what moved our parabola left or right. While we generally think of negative as moving to the left, in this case we need to remember that a negative value moved our parabola to the right. It's at the value of b, 0, that we would now have our vertex. And likewise, if we had x plus b within our brackets, and that's all squared, this would move our parabola left by b places. And the vertex would now be negative b, 0. Alright, this brings us to the end of our lesson on parabolas. Good luck with the exercise.